Good day, sir. This is my report about beyond logistic regression in Python. Logistic regression is a fundamental classification technique. It's a relatively uncomplicated linear classifier despite its simplicity and popularity. There are cases, especially with highly complex models, where logistic regression does not work well. In such circumstances, you can use other classification techniques. First, nearest neighbors, naive-based classifiers, support vector machine, decision trees, neutral network. Nearest neighbors, or KNN, is one of the simplest machine learning algorithm based on supervised learning technique. Assume the similarity between the new case data and available cases, and put the new case into the category that is most similar to the available categories. This is the example of KNN. Suppose we have an image of a creature that looks similar to cat and dog, but we want to know either it is a cat or dog. So for this identification, we can use the KNN algorithm as it works on a similarity measure. Next, the naive-Bayes algorithm is one of the crucial algorithms in machine learning that helps with classification problems. It is derived from Bayes' probability theory and is used for text classification where you train high-dimensional datasets. This is the example. Some base examples of the Bayes algorithm are sentimental analysis, classifying new articles, and spam filtration. Classification algorithms are used for categorizing new observations into predefined classes for the uninated data. Next, support vector machine or SVM is one of the most popular supervised learning algorithms, which is used for classification as well as regression problems. However, primarily, it is used for classification problems in machine learning. The goal of the SVM algorithm is to create the baseline or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. This best decision boundary is called a hyperline. This is the example. SVM can be understood with the example that we have used in the KNN classifier. Suppose we see a stray cat that also has some features of dogs. So, if we want a model that can accurately identify whether it is a cat or dog, so such a model can be created by using the SVM algorithm. Next, a decision tree is a non-parametric supervised learning algorithm which is utilized for both classification and regression tasks. It has a hierarchical tree structure which consists of a root node, branches, internal nodes, and leaf nodes. This is the example of decision tree for play tennis. Neural network. Just like a human brain, a neural network is a series of algorithms that detect basic patterns in a set of data. The neural networks works as a neural network in the human brain. A neuron in a neural network is a mathematical function that searches for and classifies pattern according to a specific architecture. It is possible and important to talk about each of this topic in details and for a long time, but my goal in this article is build a model and work on it together. This is the example. Build a simple neural network model in a TensorFlow. To make a laptop buying decision, learn why neural networks need activation function and how should you initialize their weights. Conclusion, you know what logistic regression is and how you can implement it for classification with Python. You use many open source packaging, including num to work with arrays and matplotlib to visualize the results. You also use both scikit-learn and stats models to create, fit, evaluate, and apply models. And this is the step. Import package, function, and classes. Get data to work with and, if appropriate, transform it. Create a classification model and train or fit it with existing data. Evaluate your model to see it is performance is satisfactory. Apply your model to make prediction. Thank you.